Hi guys, I hope you all are doing well. In today's video, we are going to learn about the applications of trigonometry. That is the class 10 mathematics chapter 9. That is some applications of trigonometry. In the last video, we saw the concept of trigonometry. We learned what are trigonometric ratios, how do we calculate them, and what are some standard trigonometric ratios, and what are the trigonometric identities, and how do we use them in general. Okay. So today we are going to learn its real life applications. How trigonometry is applicable in real life, and how do we calculate heights and distances using the concept of trigonometry. In this, you need to just know about some of the terms that are we going to use. That is, if I have a building, let's say this is let's say BC is a building. Okay. And there is a person that is standing over here. If I zoom in, you may see that there is a person that is standing over here. So ED is the ground level. ED is the ground level. I denoted by G and D. And let's say I have a person that is tall and his height is AE, or that is equal to BD also. Okay. And from here, from the eyesight of the person, let's say his eyes are over here, he is looking at the top of the building. So therefore, his eyes make an angle of elevation. Okay, so this is the angle of elevation. So when I see something in the upward direction in the sky, then there is a certain angle that is made between my eyes and between the ground level. That is, if I'm looking into the camera, that is the ground level. And if I look over here in the sky, then there is a certain angle that is made that is known as the angle of elevation. Angle of elevation. And the line that follows my eyes, the line that is followed by my eyes is known as a line of sight. So basically, this is a line of sight. So AC over here is the line of sight, or maybe it is also known as the hypotenuse. Okay. Uh, DC is the height of the building over here. Okay. I hope that is understood. If we transform it into a right angle triangle, we can draw it as like this. Thus the line of sight is a line drawn from the eye of an observer to the point in the object viewed by the observer. So, if I'm viewing the top of a building, so the line of sight is the line drawn from my eyes to the top of the building. And the angle of elevation of the point viewed is the angle found by the line of sight and the horizontal when the point being viewed is above the horizontal level. So if we see this, my eyesight is at a normal level, that is horizontal view. And if I look up at at an object in the sky, thus the angle made between these two lines, then that is a line of sight and the horizontal level is called the angle of elevation. One more concept is of angle of depression. If I am standing at a higher level and I look at a object or a point on the ground, therefore, my normal level was this. Initially, that was a horizontal level, and now my line of sight um is at a lower level from my horizontal level. So this is my line of sight over here. So thus the angle made over here is the angle of depression, that is looking downwards. Okay. So the angle between the line of sight and the horizontal level, when I look something at a lower level from my height, then it is called as the angle of depression. One more thing that you can notice over here is the horizontal level and the ground level are parallel to each other. So therefore, the angle of depression over here, let's say if it is alpha, so this angle would also be alpha. So this we will use this concept in in some of the questions. Okay, now you are given with many examples and only one exercise over is given in this chapter. So I would be solving one question from the I shall be solving one question from the uh, exercise to make your concept clear or to tell you how to solve the question. You may refer the solved examples that you can solve the exercise questions, that you have to do it on your own. If you have any doubts in the question, you can put it in the comment section. I would make a specific video clarifying them, or I would just put the solution into the comment section. Okay. So now we will solve one of the questions from the from the textbook. Okay, so we shall be solving question number 8. So firstly, we'll read the question carefully, write all the given data, and then solve it. Okay. So a statue that is 1.6-meter tall stands on the top of a pedestal from a point on the ground. Stands on the top of a pedestal. Okay, a statue 1.6-meter tall stands on the top of a pedestal. Pedestal is basically a structure that is maybe in a circular shape or a square shape that is used to place the statue over it. You may have seen in your city or somewhere. Okay. So let us say this is the pedestal. This is the ground level. Okay, and there is a statue. I'll denote the statue using this small. Okay. I'm sorry for my drawing, but it's okay. That can be this. Okay. So we are given that a statue 1.6-meter tall stands on the top of pedestal. Okay. The height of the statue is 1.6-meter tall. So this part, this part, this much part is 1.6-meter tall. Okay. Okay. Cool. So from a point on the ground, the angle of elevation of the top of the statue is 60 degree. Okay. So a point on the ground, let's say this is the point on the ground, the angle of top of the statue is 60 degree. So the angle of of the statue, if I connect these 2 points, this is the top of the statue, the angle is 60 degrees. Okay, this is 60 degree. And from the same point, the angle of elevation of the top of the pedestal is 45 degrees. And we need to find the height of the pedestal. So now the height of the top of the pedestal is this much. The top of the pedestal is this point. So therefore, we need to find the angle that here we are given 45 degrees and here it was 60 degrees. The whole angle over here was 60 degrees. Okay. I hope the drawing is thoda clear. So we need to find the height of the pedestal. Let us denote the height of the pedestal. So okay, now we will just we'll draw this in a form of triangle. Okay. Let's say uh, this is a whole part. Okay, this is the ground. Uh, this is the triangle. Okay. So let's say this is the point. So therefore, my statue is 1.6 meters. That is this much. And let's say my height of pedestal is denoted by small h. And let us say just a second. Huh. And let us say our total height, the total height of the statue plus pedestal is capital H. Let us denote by capital H. Okay. Now there is a point over here. Let us say, so that point, from that point angle of, so we need to draw two lines over here. Okay. So this angle is 45 degrees. That is up to top of the pedestal. Let's say A, B, C, and D from the point D. And to the top of the statue, the angle of elevation is 60 degrees. It is quite easy. It is quite obvious that if the height of this point is from point B of point A is less than point A, so the angle would also be lesser than that of angle A. Okay, I hope that is clear. So let us say this distance is x. Now we would apply the concepts of trigonometric ratios to find out the value of small h. We need to find the value of small h. So our solution begins like this. Now let us say h is equal to small h plus 1.6. Now the units are in meters, so we'll calculate all the things in meters only. Capital H is 1 point h plus 1.6. Let us say this is the equation 1. Now we will use the trigonometric ratios to find out the other things. So now if I consider the pedestal, I have the angle, my angle D is 45 degrees and small h is the height of the pedestal. So if I use tan over here, I can write it as tan D is equal to small h upon x, right? That is this side over this side. That is the side opposite to the angle upon the adjacent side. Okay. So now tan D, I know tan D is 45. D is 45 degrees. So tan 45 is equal to h upon x. Now we know that the value of tan 45 is 1 is equal to h by x. So from here we get that x is equal to h. Let us say this is our equation 2. Now we have got that x is equal to h. ठीक है. Now we will move further. Now we will take the whole part, that is the height of that, we'll take capital H into consideration, and we will use the angle 60 degree that is given to us, that is at the top of the statue that is given, that is 60 degree. So now here it will be tan D. Again tan D would be capital H, that is the whole length, upon x, that is the adjacent side, that is whole h upon adjacent side, that is x. Now my h is capital H is given as 1.6 plus small h from equation 1. Over here we know that capital H is h plus 1.6, and now we also know that my small x is equal to h from equation 2, so I can replace it with small h also over here. Now I know that tan D is equal to 60 degrees. So D is 60 degrees. So tan 60 degrees is equal to 1.6 plus h upon h. You cannot cancel h and h over here because the h that is in numerator is in addition with 1.6. So you cannot directly cancel out each other. Now we know that the value of tan 60 degree is root 3. So I'll replace it with root 3 and write it as 1.6 plus h upon h. Now, if I transfer h from right hand side to the left hand side, I get root 3h is equal to 1.6 plus h upon, okay, nothing in the denominator. Hmm. Okay, 1.6 plus h. Now, if I take all the h terms into one side and the other term onto the another side, I get root 3h minus h is equal to 1.6. Now, you can do two things, that you can put the equation as it is, or else you can take h common, root 3 minus 1. If I take h common, I get h 1.6, and if I transpose it, I get h is equal to 1.6 upon root 3 minus 1. So this could be also your answer, or else you can use the standard value of root 3, that is 1.732. So it is not rational value, it is an irrational value. It goes up till infinity, but in general, we can take it as 1.732. So if I write it as h, or now using it in equation, root 3 minus 1 equal to 1.6. If I were to write it as 1.732 minus 1 equal to 1.6, and also I can write it as h is equal to 1.6 upon 0.732. Now, if I calculate it, just a second, 1.6 divided by 0.732, I get 2.185. So the height of the pedestal is 2.185 meters. You can keep the answer is in this form also, or else it would be nice if you calculate it using normal basic division. So now this is not asked in the question. So finally we have got the solution for the answer, that the height of the pedestal is 2.185 meters. If we were asked that calculate the total height, that is the height of statue plus height of pedestal, we would have just added the individual heights, that is h plus 1.6. that is 2.185 plus 1.6, that is approximately equal to 3.785 meters. So yeah, that is the solution for this question. Similarly, you can use the concept of trigonometric ratios and trigonometric formulas to calculate to solve all the questions that are given in exercise 9.1. I hope that the concept is quite clear and you can solve the questions easily. Just know the core concept, visualize things, give all the notations, try to transpose the equations and use the values we get in one equation and put it into the another equation. Try to minimize the variables so that we get the answer as easily as we can. So that's it for this video. We'll meet in our another video. We'll cover chapter 10. So yeah, that's it for the applications of trigonometry. We are done with chapter 9. Thank you so much for watching this video. Have a good day. Practice well. Take care and bye bye.
वीडियोस बनाने हैं, फिल्मोरा है ना।